Okay. Good evening, everybody. Thanks for having me here. My name is Berend Onnes. I work for Schiphol Airport. And I'm going to give you a presentation on what we do on operational flow forecasting at Schiphol. Yeah, let me tell you a little bit what we're going to do the next half an hour about. So first of all, I'll give a brief introduction about myself, about the company I work for, Schiphol Group. Then talk about traffic analysis forecasting team and exactly what do we do for the implementation of machine learning. Yeah, what does the process look like? How do we do machine learning? How do we get it implemented? And what are the key success factors? And then there is room for some questions. Yeah, first introduce myself maybe. My name is Berend Onnes, working for Schiphol for just a bit over 10 years right now already. Prior to that, I was working for TNT Express. It's quite nice to tell maybe that they had their head office in Hoofddorp. I was living in Amsterdam. And already at that time, every time I had to go to the office in Hoofddorp, I switched trains at Schiphol and I just came up at Schiphol Plaza and I felt the energy of Schiphol and like all passengers coming and leaving and trolleys, hello, goodbye feeling. So already at that time, I thought like, whoa, I wish I could work here one day. And well, I managed to find a job. Fulfilled over the past decade 4 different types of roles. So did in the consumer department, financial commercial analysis, capacity management is the second role. The third role is program manager for CDM, collaborative decision making. That has to do with integral planning throughout the sector where air traffic control and airlines and airport share their planning and try to run the operation as smooth as possible. And now since 3 years already, just a bit over 3 years, I'm head of the traffic analysis and forecasting team. When I came in, there was quite some legacy, some really good Excel models which told about forecasting. And when I came in, I thought, hey, maybe we can do stuff differently. So that's what I'm gonna tell about. But hey, it's Data Donderdag, so I thought I can tell you about feeling and emotion, what I like about Schiphol, but maybe I'm just gonna get your attention with a few numbers. That's what we're here for, Data Donderdag. So about Schiphol, what's Schiphol exactly like? So right now, Schiphol serves 326 destinations worldwide directly. That makes Schiphol, the best connected airport in Europe. The number of air transport movements, nearly 500,000 per year. There is no airport in Europe that does that. So it's, if it comes to air transport movements, the busiest airport. And this still is excluding general aviation. Where all rock stars travel with, not even included in that number. A whole lot of cargo. Schiphol Group has 67 million passengers, but let's say Schiphol location, so that's only the airport in Amsterdam, nearly 70 million passengers, which is, let's say, for a small village as Amsterdam, basically, as if you would compare it to Paris or Berlin, is a massive amount. And what's nice to know is that about 1 out of 3 passengers at Schiphol has nothing to do with Amsterdam. They're just there to transfer and to connect to other places. So that's also what makes this process so critical on flow forecasting. People really have connections to make, and we need to make sure that we deliver the right process. This is what we in our team do. So I'm head of the traffic analysis and forecasting team. We do a few different things. One bit is reporting and analysis, so we'll look back at what happened, look at network quality, we benchmark, we look at opportunities and threats, so what's happening, Brexit obviously, what's happening in the Gulf, with Qatar being isolated, or with Turkey right now. Hey, what's happening there and what would it, to what extent would it affect our network? Looking at regional airports, or also development of Lelystad. I can tell a lot about that, but not for tonight. What I'm going to tell most about is the thing in the middle, is we look at capacity. So we do different kinds of forecasting. We do short-term forecasting, which is really for operational purpose. Make sure that we've got enough staff, security staff or border police, to have smooth operations. Also for the medium long term and long-term planning, we make forecasts. So this afternoon we've just been talking about, hey, what would Schiphol look like in 2050 about, and do we still have enough capacity at that time? We look at limitations and all those kind of things, let's say about constraints if it comes to what exactly can we accommodate at Schiphol. And then there's some commercial bit, but I won't bother you with that. So that's already the brief introduction. Then, so when I came in 3 years ago, there was quite some beautiful legacy of people trying to forecast, and sometimes, nearly took a ruler to say, okay, this is what we had last year, then probably this is what we're going to expect this year. I thought, hey, we're going to do stuff new because it's becoming more and more important, the work we're doing. Schiphol is growing really rapidly, so we need to get our act together. So basically, what's the importance of forecasting? It's for operational planning. So I think just a bit over a year ago, in the May holidays, 1.5 years ago, things went terribly wrong with, not only forecasting, but also operational. There were big queues, and then all of a sudden you see in the media, like, oh, things run out of hand at Schiphol, and it's not under control. So we need to make sure that we forecast the right quantity of passengers to go through, especially the security lanes. Normally that's the bottleneck. That's really important. On the other hand, we need to make sure that we're not over-forecasting, because at one security lane, there's 5 persons are working there. It's staff who are, to some level they're quite skilled, let's say. So it's hard to find them in Amsterdam area, so sometimes they need to drive for an hour to get there. So bottom line, really expensive staff. So if we say we expect passengers and they're not there, then 6 people at a time do nothing, and costs increase really, really rapidly. And think of it, if you take the airplane to London, what is your ticket cost? 50 or 100 euros. So cost is critical in aviation. So that's what we work on. Lucky enough, or I'm happy to say, proud to say, that this summer everything went really smoothly. We had the busiest summer ever. There were days that we had 235,000 passengers on one day through our terminal. That's the entire arena times 4.5. Just poured on at Schiphol in one day, and make sure they go through all processes, they board on time, they take their baggage. So it's immense what's happening out there. A little bit about forecasting. So what do we actually do? How do we create our forecast in aviation? What exactly are we doing? So the main thing is, our goal is, we need to make sure we have low waiting times, little waiting times, and very low cost. So those are the things. Forecast accurately, basically. So it sounds very simple. Probably you all data scientists do really complex stuff, and what we do maybe very easy. You get a flight schedule which says, okay, what's the schedule time, what's the destination of the flight, how many, what's the aircraft type, and how many seats are there. If you got that in place, then the next step we do is, okay, how many passengers actually do we expect per movement? And not only the total number of passengers, so we look at a seat load factor, so if you got 100 seats, 85% load factor, but we also try to estimate how many are destinating traffic and how many are transferring, because transferring passengers have a different flow through the terminal compared to O&D, or destinating traffic, as we call that. Sorry for the abbreviation, I try to avoid them. Destinating traffic or local borders. So once we got that, basically we know how many people to expect, and those first 2 bits is what my team actually does. And then we hand it over to operations. They make a kind of flow forecast. So they see, okay, if this is the flight schedule, how do the passengers board, via which gates do they leave the terminal? And what are their reporting patterns? So when do they report at the check-in? When do they report at the security? And at what time do they go to the gate? So once they know that, they make a kind of overview on every 50 minutes, how many passengers do we see to report at the security lanes. And then the only thing they need to do is the fourth pillar is planning the staff. So they say, okay, what's the productivity of a security lane? 6 people, how many, productivity of lane, it sounds really rude, but it's the throughput maybe is a more decent word to use. So yeah, exactly what's the throughput time of one passenger. And obviously that also has to do with weather. So in summer, if you don't wear a coat, it's not raining, you're not having an umbrella, you could go through in 5 minutes. If it's wintertime and it's wet, or you got summer holidays, you're just once a year you step in an aircraft, or maybe once in a lifetime, it's taking ages to get through. So there's all variation in this process, and what we need to do is need to make sure that we forecast it as accurate as possible. But then forecasting, I want to say I'm lean, some people call it lazy, but then I think like, hey, why would I start forecasting stuff myself, make stuff up myself, whereas maybe airlines can tell me way better that they know how much tickets have they already sold. So if I need to look at a load factor of a flight, why would I find it out myself? They know it, what their sales is. They got statistics from their booking platform, how many people are orienting on certain flights. They also manage their sales. They do a kind of, it's called yield management, make sure they maximize their revenue. So if they see this flight is, the sales not going fast enough, they could decide to have a promotion or not. So bottom line, why would I forecast myself, whereas I maybe be lazy and just say, okay, airline, you know way better than I do how busy it's going to be tomorrow. So my first thing before I start with statistical models or with machine learning is basically be lazy and make sure that in this flow that at least I get the share of airline input, that I increase that. So there's other bits I can do. I can look at slot files, I can have market insights, I could pick up the phone and call airlines to just check like, hey, are you flying with a 777 or a A380? But the easiest just make sure I've kind of interfaces and receive data from them. So in most of the cases, that's happening right now. We're growing there, even though airlines are reluctant, because this whole game, what I'm mentioning there on top, is very confidential, because airlines, they keep on playing with prices and they don't want to give away if their route is successful, yes or no, because if it appears to be a successful route, the day after there'll be a competitor to start competing against them. So we never get all the information. And also, I think, okay, being lazy or being lean is good, but I also want to stay in control. I want to make sure that the forecast we're giving, that does make sense. So I don't want to be completely dependent on an airline, like if there's stuff in their system, or if they're grumpy and say, oh, you're not going to get this for some reason. I want to be in control. And secondly, sometimes, you could question yourself, like, hey, if you're a really small airline, I would say, like, oh, I'm always fully booked and have a large aircraft. So at least I'm sure there's enough security staff to give me a smooth process. So we want to check that and challenge that. So see the information we get, does it make sense? And sometimes, can we decide it, or can we forecast it better ourselves? So what did we do is especially make the flight schedules we're going to receive, and that's not so hard because they're selling tickets, so we can find out what a flight schedule is. But especially, make a planning tool or a forecasting tool to see, okay, how many passengers do we expect per flight? This is exactly the domain of our team, so I'll dive into that. So we thought, okay, let's develop a tool with machine learning. Bright idea. So we started off, and there were a few guys who said, hey, it's not that hard, you know. We got some promising results. Just like 2 days of working, I got my first machine learning results. It's nearly as good as what we got. So we're nearly there. Throw away the legacy tools, and we're good at forecasting. So that was really promising. But, hey, that last 5%, that appears to be tough. Normally, if you tell graphs, you should say, vertical axis, confidence level. How confident are you? This is time. Yeah, I'm gonna tell you about, spoil it a little bit, roller coaster it is. So you think you're gonna make it. It appears to be tough, and especially that last bit before implementation, you think, oh, how can we make it? Can we do it? And then you think like, it's not working. It's not user-friendly at all. And people start doubting it. Like if we make a forecast, which is maybe nearly as good as what we used to have in our legacy tool, people say, yeah, but explain, why should we hire so much staff? Because we're gonna spend, open 3 lanes more than we were supposed to, due to this machine learning. Explain to me why, what flight, and then we had a hard time to explain, hey, why did we come to this forecast that we've shared? So confidence level was really low. But then we thought like, okay, the idea was good, and maybe it's a game changer, it's serious stuff, we need to get organized. So we organized like in a better way, started off a real project, get the right people, work more with the data innovation lab at Schiphol. So hey, we're forecasters, not real data scientists. So we brought in a few more professionals, and we got confident again. And we said, okay, we're gonna make the best, and we're gonna make something really cool, full-blown, and as good, no, way nicer than we used to have, with better forecast, and also visually attractive with buttons and a beautiful graphical user interface. And it's gonna get better than we've ever seen. But yeah, and it looks great, and we're nearly there. It's not 95%, but maybe 98%. We're really close. Now make it robust so that we can really use it and know what's happening in the tool. Then we tripped, let's say, over the thing, but then we need to make a graphical user interface, and how can we exactly make it work always? And then there was, it's a nightmare to exactly rebuild the switches you saw in the legacy tool. And so again, we failed, and the confidence level went down. But then we thought like, hey, don't forget the machine learning engine had really promising results. We saw that our results were better than what the legacy tool gave us. The only thing is, we weren't prepared to use the new environment because the people in my department maybe weren't skilled enough. They were good at Excel, Visual Basic, and some other legacy tools. But hey, machine learning, maybe you need to change your skills a bit. That, okay, you don't have a perfect graphical user interface, so you need to be a little bit more of a technician, but you can start using it, and maybe that works. So that's what we did. And by the way, we found out that the legacy tool basically sucks big time as well. So the pain to say goodbye to what you have, don't forget about that. So there's always stuff saying, the new world isn't perfect. Yeah, but the old world really sucks. So we need to carry on and go for it. And that's what we did. Then there's a whole bunch of bureaucracy, and especially at Schiphol, people say like, but if you're gonna do this, you need to organize stuff here and go through this desk, or like, screw it. We're just gonna continue and make sure this part is working, and then, for example, we're going to migrate to a data hub, or first we're gonna get this working, and then we'll just make sure that it's in the right environment. So this is a little bit the roller coaster we went through the last 2-3 years when I was in the team. So now we are there. We just this summer delivered our first machine learning forecast, and it was quite successful. So a few things that we came over, and I'd like to share that with you. The first is, so what do you need to do? Maybe this is all easy for you, but let's say you need to experiment with forecasting. So we used to have forecasters who say, okay, what happened in the past? Learn from that, and then bring that to future. What you need to do with machine learning, you say, okay, what do we do? You're going to do some backcasting. So you train your machine learning algorithm on data until 2016, and then you see, okay, can I forecast 2017 and 18? And probably if I can forecast 2017 decently, then most likely this algorithm does the right thing, and I can apply it also to forecast next summer. So that helps a lot. So we predicted the past, we needed to be careful to keep a clean model, so to really not take aboard already patterns that we discovered later on, so do a real comparison. And what's nice, you can play around with it, get some feedback, like, okay, hey, how good was it actually? And then I'm going to tune the model a little bit. So we did tune the model with adding some weights. I don't want to get too much into deep details, but we found out that, for example, holiday periods are really important. Aircraft size is important, apparently. Smaller aircraft, they determine to a more extent what the outcome is going to be than a few larger aircraft. So we had some tuning there. Obviously historic years. So these are, let's say, the weight factors. So most recent years way heavier than previous years. You see that holidays, they weigh heavy. And this was for creating a summer 2017 schedule. Or to create a summer schedule, so you see that the winter periods are not weighing really heavily because it's a different kind of dynamics and it's a different kind of, let's say, timetable. So we managed to tune and to get the model better and more accurate. So we were quite happy with that, but we needed to check, okay, is this good enough to use and can we throw away what we had? Because people said like, yeah, it's new when we don't understand what's happening. We didn't understand, by the way, what the old system did, but that was a black box, but we knew it was a black box, and yeah, we survived. So tell me, is it better? So it's really important to measure. So what you see here is all flights per 15 minutes. That's a really important KPI because we plan our security based on 15 minutes brackets. And what we compare here is the blue is the machine learning RMSE, so that's a term of deviation, how much do we deviate. And the brown-orange one is the legacy tool, it's called Beyondra. So what do we see is that this is the spread, so where does machine learning or where does the forecast too little and where does it forecast too much? So what do we see is that the machine learning pattern is more slender, let's say. So there's less deviation. So already this shows, well, this helps, and it seems to be that our machine learning algorithm is better than what we used to do. So this is quite convincing. So I thought we're there. And then people start asking tricky questions. Let's say, this could be per 50 minutes, but did you look at it from a different perspective? So we did these same exercises for single flight level. So maybe 50 minutes is okay, but this critical flight of KLM to Quito, how good are you at forecasting that? So we looked at single flight level. We looked at daily totals. We looked at groups of airlines who share check-in facilities or who share other facilities. And also by destinations, like is there a kind of bias? And also if we see we were off, we could tweak our model and think, okay, this is a kind of slicing or dicing. This is a kind of dimension where we're off, so maybe we can learn on that. So once we put all these ticks in the boxes, people got more confidence and said, okay, well, maybe it's not that bad after all. What we then found out is historic data. So reliable training material. If you say machine learning, you need to train the machine. We trained on historic data, which wasn't fully accurate. What we found out, I think, maybe we have to start laugh or cry about it, I don't know. We looked in our historic database, and for example, I found out that, really don't broadcast this. No, I found out that sometimes we had 100 seats, and in our historic database, that flight had 160 passengers. So if that's what we have in our historic database and we train an algorithm to forecast future, what's it going to bring? Minus 61 passengers to Mumbai. So what does that mean? And how can we forecast? Do I need to hire security staff? Minus 6 people to help these people to board? We had freight being shipped from Amsterdam all the way to Amsterdam, which is really awkward. So all these data errors in historic data, they screw up the future forecast. So that's where we now find out that if we want to improve our forecast, we get more data from airlines. That's really helpful. But what's also helpful is that our historic data is accurate, more accurate than it is today. Lucky enough, these are a few, but let's say the worst examples. The biggest chunk is okay, but we need to get this away because people start laughing about it. They say, hey, that's your machine learning, eh? Forecasting minus 70 passengers to Mumbai. What's that? That's crap. No, that's historic data. That's the algorithm, how we trained it. So this is key, and I think that's one of the things. It's not as cool to do, but make sure your historic data is accurate. And what do is we measure how accurate actually is our forecast. The lines are a little bit thin, but we created the kind of dashboard to closely look at, okay, what's the total number of passengers, and what's again the RMSE, so the root mean squared error, the deviation. How far are we off on the total number of passengers on local borders or transferring passengers? And so every time, like, there's a whole bunch of selections we could make. So this is winter 2017, departing flights. Oh, you could even say what weeks are scheduled or day of the week you could select. Or and you can see, okay, how good actually are we at this? And if there's a deviation or there's a long queue, we can say, hey, where did it go wrong? And we could drill down. So this really helps also, again, to train your algorithm in the end. Also important, be thankful for cooperation. You see a similar kind of graph. Let's see, yeah, like the previous one, but right here it's just KLM. So you can see that the RMSE is way lower than in previous graph because we receive data from KLM. So thanks to their input, we are way better at forecasting and our output is way more accurate. So yeah, we must be grateful to them, and that's what we tell them. We say, hey, you send us this, and you know how much that helped. That's so cool to see. Well, there's just a few days that were busted, but that's because that was the 16th of January. There was snowfall and de-icing. There were thunderstorms on the 28th. So hey, we were off there, but I can't predict a thunderstorm 2 months in advance. So yeah, too bad. But this is really what helps, and look at the actual data. Is there more? Yeah, so we look at where can we improve. We also look at, think of the first chart I was showing on, okay, so how good are we? How good is our flight schedule? How accurate is that? To what extent does that deviate? Then you got, and again there you see if there's disturbance, flights are being cancelled. So yeah, we were off in those days. How good is that? The number of seats, how accurate did you forecast that? Maybe you need to tweak on that, so you can say like, okay, most of the things were right, but we just expected a larger aircraft, but apparently they have smaller aircraft. Or learn from that, the transfer shares and the total load factor. So that exactly helps us to find where do we need to tweak our model, where do we need to get better. So yeah, that nearly brings me to the end of the presentation. So some roller coaster learnings, I would call them. Let's say this is what we went through, and I thought like all the things that the machine learning algorithm in itself maybe is not that hard, and yeah, you get some promising results, and you think like, okay, we're gonna get there easy. But really make sure that we got organized really seriously. So at first there were just a few guys in my team who thought like, hey, this is new stuff and I can try programming a little bit. But in the end, we went working with our data innovation lab, also with people from just up here, from GoDataDriven, to build a good algorithm, to build a good machine learning model. Also really important, when exactly do we believe it's good enough to go? Because we were trying, and it's never perfect, and it will never be perfect. But at a moment in time, you need to say, okay, if we've got these 4 items to tick, let's say, so on a 15 minutes bracket, on a flight bracket, on all kind of levels that it's better than we used to have, we believe it's good enough, and we're gonna use it. So that's also what you need to be really clear about. Yeah, make sure you have skilled professionals on board. Either you hire them or you get them in your team. And then also very important, new tools is new user skills. So we went the wrong way with developing graphical user interfaces and making stuff easy to click, and it just didn't work out. Like right now in my team, everyone can work with Python, and we can all run through the code and we can see like, okay, so this is actually where it goes wrong. So okay, you need to have a little bit more skills. Don't need to be able to write the entire code, but at least you need to be able to track it and see where does it go wrong and where do we need to tweak it. So new user skills. Lucky enough, I've been able to change quite a few, bring a few new people in the team with new skills, really important. To compare and validate, I think still today we're working, and I think Rock as well is helping out on that, on making comparison tools. So to look at, okay, how good is this compared to what we used to forecast, and also compared to how is this compared to last year. So actually, do we see a growth of 10%? Does that make sense, yes or no? Or compared to what the airline delivers to us and what we think ourselves, and if not, we're not going to blame him, but just to check, like, hey, validate, does this make sense, yes or no? Really important. And the last one is the dullest one of all, but the most important, and I can't stress it enough on Data Donderdag, data accuracy. It needs to be accurate what we train our models on, and I think we've underestimated that, or found some of those nasty mistakes in our historic data. So that's how we're working right now. We did the first 2 steps, so forecasting the passenger numbers with this machine learning. Hopefully in future we can expand it to also look at the reporting patterns and the productivity of security lanes to make our entire flow forecast based on this machine learning. I hope you enjoyed the presentation. I don't know if there's any questions.
Thank you. Berend, can you hear me?
Yes, I can hear you. I can repeat your question if you like, then okay. For the broadcast.
What I see is you have to work with others supplying data to you. So, as you said, the most important is data accuracy. How do you ensure that you get consistent data from the partners you work with? Because that is in the end also the source for your success. And are they really happy to operate or to cooperate with you? Because it's also in their...
so there's 2 questions. How do you check the accuracy? Well, common sense helps a lot. So every time we see things that are off or that don't make sense, we get a trigger. So we now define red and orange alert. Red alert is way off, minus 61 passengers, wrong, stop, don't use it. The examples I just given, that's wrong. So that's what we can do. And then we can say some bits are suspicious. So things you would never expect. Like normally this flight has a low load factor and now all of a sudden we see a high load factor. Is that actually correct? You used to deploy this type of aircraft and now you get that type of aircraft. Is that off? So anywhere where we see changes in the schedule or changes to previous update, we can track that. So that's the first part of your question, that we build in our own checks. And what we try to do more and more is these checks, we apply it on the data we receive, and we do those checks, we apply them again on the forecast we send out. So also the thing after processing, we do the same checks again, because if I don't believe the historic flight has 60 passengers on board, or minus 60 passengers on board, I don't want my forecast to tell somewhere that it has minus 60 passengers. And your second question was on... Sorry, what was your second part of the question?
Well, it is more about...
Oh, yeah, sorry, I recall you...
Supplying your data to... how do I say? Supplying your data to your partners, because they also have to benefit from it. Are they ready to cooperate with this? Because you're supporting them as well to have a
so especially the airline data, thank you, especially the airline data, so they were a little bit doubting whether to share this highly sensitive information and whether they could rely us to treat it. But then the slide I was just showing with the low RMSE of the KLM flights, so I can tell them like, hey, if you forecast like so as good as you do right now, then you got a low RMSE, and that will turn out to give you low waiting times in the terminal and hopefully low costs. So if we give them, we show them actually what the value is, then they're really willing to cooperate. Yeah.
One final question. There was one question here.
Well, it was, thank you for your sharing your experiences, by the way. And I was thinking, is it also maybe a possibility to have fees if they don't deliver you the data? Because the airline data was key for your experience. Maybe it's interesting to give them a fee if they don't share it, because as told, it's beneficial to them.
I think that's in the end that's something either we give them a bonus or a penalty or so. Normally it's in the Schiphol rules and regulations that if you operate a flight at Schiphol, we now just since this year said, okay, if you fly here, we ask you to deliver your pre-flight and your post-flight information in an accurate way. We're being very gentle with airlines, and maybe there will be a day that we're going to push harder and to say, okay, either you're going to get a penalty that a fine will be like really hard, but you could also say, okay, if you don't plan accurately, then we'll put you on less attractive gates, or we can best planned, best served, or so. So we could find some measures and at least reward airlines to do this as good as possible. But hopefully, I'm in favor of the carrot. So maybe we could make like a kind of fun competition or so, like, hey, who's best at forecasting his own business? All right.
Thank you very much, Berend, for your presentation here tonight.
Thank you.
Not only for making our lives at Schiphol a bit better, but especially